Think about the last time you baked a batch of cookies. You press out your round shapes, but you are always left with a few odd scraps and clumps of dough that don't make it into the final batch. Our solar system began in a similar way about 4.5 billion years ago. A massive, swirling cloud of gas and dust acted as the dough used to build the primitive planets. But the process didn't use up every bit of material. Billions of leftover scraps were left scattered and floating freely across space. Today, scientists organize these leftovers based on two simple things: what ingredients they are made of, and where they ended up parking in our solar system. Because they were never pulled into a planet, these objects still carry the original recipe of minerals from the very beginning of our solar system. The first recipe gives us the asteroid. These are small, rocky, and sometimes metallic objects that orbit the Sun. While they are scattered throughout space, the vast majority are caught in a massive traffic jam right here, in a wide band between Mars and Jupiter, called the asteroid belt. Since they are made mostly of rock and metal, you can think of them as the hard, dry crusts of our planetary recipe. Unlike planets, asteroids are usually too small for gravity to pull them into perfect spheres. Instead, they look like this: lumpy, uneven, and covered in holes from billions of years of colliding with other rocks. They are the solid building blocks that never managed to fuse together into a full planet. Our second recipe is the comet. Instead of solid rock, comets are more like dirty snowballs, made of ice, dust, and frozen gases. These icy leftovers formed in the freezing, dark outer edges of the solar system, far away from the sun's heat. Out in the dark, comets are too small and dim to be seen. We only notice them when their long orbits drag them close to the sun. As they warm up, the ice turns directly into gas, causing the comet to boil and vent dust into space. This creates the famous tail. Because of the pressure from sunlight and solar wind, that trail of gas and dust is always blown pointing away from the sun, even when the comet itself is moving back out into deep space. If you look closely, you can actually see two distinct tails, a broad one of heavy white dust and a thinner, straight bluish tail of charged gas. That glowing trail is the visual evidence of an ancient, frozen leftover actively melting away as we watch it. As asteroids collide or comets melt, they leave behind tiny, broken crumbs of space rock. Scientists name these crumbs based on where they are. As long as a small piece of rock is floating freely in open space, it is called a meteoroid. If Earth's orbit crosses paths with that rock and it hits our atmosphere, the extreme friction causes it to burn up in a bright fireball. At this stage, it is called a meteor. These are the shooting stars you see up in the night sky. Despite the name, they are not actual stars. They are just small rocks catching fire as they fall. If the rock is large enough to survive that heat and actually hits the ground, it earns its final name, a meteorite. The heat of the fall physically changes the rock. It arrives with a blackened, glass-like skin and shallow indentations that look like thumbprints pressed into soft, wet clay. The next time you see a flash of light in the sky, you are watching the final moment of a rock that has been orbiting the sun since before the Earth even existed.